Hello. In this video, we are going to be looking at another tool for extracting data out of a graph. And in this video, we will be looking at a piece of software called ScanIt. And I am a big fan of this, and I very much appreciate the nice folks at Amsterchem providing this tool for the world. So you want to go to amsterchem.com/scanit.html. And there are some simple instructions because it is a simple, easy to use, lightweight piece of software. So to download it, you can just click on this link, which takes you to amsterchem.com/downloads.html. And down on the bottom here, you'll see the file, scanit.exe, and you're going to want to save it. And I've already installed it. And it's going to ask, do you want to make changes? And no, because I already have it. But it's just seconds to install because, again, a very simple, small piece of software. So then you want to run it. So you type ScanIt and you find it and you open it. And the first thing we need to do is to insert the image that we're going to be looking at. And I've got it in this folder here. And here we go. Now, part of why, there are two reasons why I wanted to look at this graph. Number one is it has individual data markers, points. The other software that we looked at is great at if you want to do the whole line, but I don't want the whole line. I just really care about the markers here. And so this is a graph that has markers. And then number two, they actually have the numbers on the graph. So once we're done, we can see how close our approximations are to the numbers on the graph. Okay, so like I said, it's quite simple. Now there is one issue with this graph, which we're about to see. The first thing we need to do is we need to set the axes, and we need 3 points. One that's somewhere on the horizontal axis, one that's somewhere on the vertical axis, and then one that's at the corner point where those two lines intersect. And so here you see the problem with this picture is that we don't have axis lines drawn in. So I'm going to just have to approximate them. It would be possible to just draw some lines onto the picture and then save the picture, the image, before you bring it into the software. If you were to do that, you would probably get a little bit more accurate numbers because I'm just going to ballpark where the axis is. And if I'm off a little bit, it's going to throw the numbers off a little bit. So the first point I'm going to drop, first pin is, I'm going to do it right here because I know the coordinates. And I'm going to say that the X coordinate is 1970. And the Y coordinate is 1.1. Click OK. And then I need to have the next point be on the same x-axis. And so here you see where I could be getting into trouble. So what I'm going to try to do is I'm looking on the right-hand side here where I've got this blown up image. And so the word 1970 is, I'm just looking at where that is on my computer screen. And I want to make another point over here. And I've got the number 2020 is in about the same spot on my computer screen that 1970 was. Again, this would be a lot easier if I just had a horizontal axis. But so I'm going to say somewhere around in here. And so I'm going to click to put my point here. And I'm going to say that my X coordinate is 2020. And the Y coordinate, I'm going to say is 1.1 because it's supposed to be at the same height as the one that I made before. So I click OK. And then for my last one, this should be on the vertical axis. So it should be straight above the first one, the 1970 point. And I think as far as I can tell from eyeballing it, again, this would be better if I had a line. But so I'm going to click it here, and I'm trying to eyeball it also so it's about the same height as that data point that says 21. So that's probably pretty close. So I'm going to say the x coordinate is 1970 and the y coordinate is 21.0. So, and then it's not a logarithmic scale, so accept what we've got. And now we're ready to extract the data. The default mode is to go and manually select the data, but the whole point of this is to make life easier. It can trace a curve if you have a continuous data set, but the reason we're using this is because I want to scan for symbols. So I selected that on the drop-down menu, and I'm going to collect the undergrad data first. So you just need to click on some data point in any one of them in the set. And I can see over on the side there that I'm pretty well centered on the data point. And so it gives us a zoomed in view of what it's going to look for on the graph. And we got to go delete this junk. So just hold down your left mouse key and erase the pixels, because otherwise it's only going to find as a data point something that has those noisy pixels off to the side. We don't want that. We just want a nice round little blue circle. It is color sensitive, so it's a little disconcerting that this image only shows in black and white. We'll do red in a minute and it'll still be black. So we click OK. And you can look quickly, you can see all the little green boxes on our blue circles. So all of them have been identified. Sometimes, there's some text or some lines, or it's a little not quite sure if this is a data point or not. And so with this slider here, you can press the right arrow and it won't be quite as choosy. And if you go to the left, it'll be a little more selective, but this looks all looks great. So I can click OK. If I want to, I can go up here and I can rename this data set and I can say this is the undergrad data set. So I'm going to go here and I'm going to click the bottom one and I'm going to hold down the shift key and the up arrow just to highlight them all. And I'm going to hit Control C and I'm going to paste them into Excel. And we're going to see how closely our extracted data matches the original data. I don't know why, but it doesn't do the points in a logical left to right order or top to bottom. I don't know. So I'm going to sort the data by the year. And you can see it got 1970, 75, 80. It's going by fives here. So it got the X values estimated properly. And then let's plot an XY line. And we'll go with straight lines because that's what the original was. And now I want to see how closely this visually seems to approximate what we started with. And then we'll compare the actual numbers that we got compared to what the original had. So to do that, I am going to insert the picture that we're working with. So I need to go find it again and historical college enrollment something. There we go. So it's pasted it on the sheet. And now I'm going to right click on it and I'm going to say send to back. So now it's behind everything else. And then I'm going to right click on the graph that we made. And I'm going to click on the fill and I'm going to say no fill. So now this is transparent and so I can see through it. And I'm just going to stretch out the graph we made, play around with it and see how closely they seem to match up. There's probably a fancier way to go about this, but this only takes like a minute. And I'm only doing this because, I want to make sure that this seems like it works out pretty well. And I'm going to say it seems like it worked out pretty well. Do that. So I'm just trying to scooch it down with my keys. And this all looks pretty great. Over here on the right side, we're not quite on, and I'm not quite sure why. Oh, but I have a guess. So, and my guess is because I probably wasn't very accurate when I was eyeballing that point along the horizontal axis over on the right-hand side. I probably put my point a little too high, so that made it underestimate the actual numbers. But overall, this worked out quite well here. And if you do have an original graph that has the axes on it, this thing works amazingly. And again, I want to thank our friends at, what are they called? Amsterchem for providing this free tool for the world. Now I'm going to move our graph out of the way and just go back and look at the originals. So we had 6.3. Originally, we came up with 6.3 and then 10.5 versus 10.6. We're off by about 0.1, although we're right on in the middle. We're right on there. We're off by 0.1. So we're off by 1/10 out of, numbers on the order of 6 through 20, roughly. And so we're off by 0.1. So we're really close. And if you, like I've said too many times now, if you have the axes on there originally, this really would work out quite well. I just want to go back and show one other thing. We can create a new data set, and again, this is just so easy. So I'm going to click on the red, and well, let's see what happens if I leave it like this. So I'll say, okay, search, and actually it found everything. I haven't always been so lucky. So I think it's a good idea to go remove that debris around the sides, but in this case, it worked out fine. Now, the one thing that you will notice is that, well, you can't see it now, but there was no data point, because when it searches, it puts a little green box over each point it found, and there's no box over here because there's no red dot over here. And I'm going to say the folks who made this graph didn't do a very careful job, because the 16.3 data label covers up the 7.4 data point. So they should have moved this 6.3 someplace so we could see that red dot. And so what should we do in this case? I would say just go ahead and use the numbers that we've got and put them in a graph if you need. And then we know what the number is, so just put it in your spreadsheet. And so again, we could rename this. We could call this total, and then we could do it again. So we could copy and paste this into our other spreadsheet. You can save the file, etc. Save the data in a file. But it's really great, and it's really easy, and I'm a big fan. So ScanIt from our friends at Amsterchem, and I hope this has been helpful.